In this video, I'm going to show you how to place the front wheel hub and bearing assembly on this Lexus IS. This is bolted onto your front knuckle and we'll have to remove the brakes for this. Let's get started. With the vehicle safely raised and supported, use a 21mm socket and remove all 5 lug nuts and then pull the wheel off. Just as a tip, if your vehicle has locking lug nuts and the special key for it, don't use an impact on it, break it free by hand with a breaker bar, then finish removing it because the teeth on those little sockets can break. And remove your wheel. From the backside of the caliper, you'll see 2 17mm headed bolts. They hold the caliper and bracket assembly onto the knuckle. So let's remove them both and then move the caliper aside. Leave this one threaded in so I can hold everything while you remove the lower. Finish removing your bolt. Pull the caliper off, but don't let it hang on the brake hose, so hang it with a bungee cord or a hook. At this point, you're going to want to remove the rotor. Sometimes they get stuck on here, and if that's the case for you, you can use 2 8x125 bolts and thread them into these threaded holes, which will push the rotor off of the hub for you. It's not recommended to use a hammer or a rubber mallet when you reuse the rotor because that gouges the surface. Mine is not stuck, so I'm just going to remove it. Our axle nut is staked down right here, so I'm going to take a small chisel that fits in this opening and push the axle nut out, or the part that's peened over, so that we can unlock and remove it much easier. That's as far as I'm able to bring it, so let's put a 30mm 12-point axle nut socket on and pull this nut off. Now what you'll want to do is take a punch and a hammer and make sure the axle and the splines go through the hub and aren't stuck in there. This one goes in, so I'm not worried about it. If yours was, you'd have to hammer it until this breaks free, and of course some rust penetrant sprayed in there would also help out. I'm going to remove the tie rod stud from the knuckle so I can spin the knuckle around. So to do that, I'm going to remove this cotter pin. Sometimes it's helpful to have a pick or a pocket screwdriver to pry this out of its spot where it locks in and then pull it out. These cotter pins you can reuse, but if you have the kind that you have to bend over yourself, those you do not want to reuse, always replace them. Use a 17mm socket and remove this mounting nut. Because this is an aluminum knuckle, I don't want to damage it by hammering it, so I'm using a tie rod separator tool that's going to push the stud out of the knuckle. Pull this out, set it aside. Now we have full mobility of the knuckle and we can turn it to better access our bolts. Now with a 17mm socket, remove the 4 bolts holding the wheel bearing on from the back. And on the other side. I'm going to spray some rust penetrant around the backside where this goes on the knuckle just to help separate these. Most likely though, no matter what, we'll end up using a fairly large hammer and trying to hammer this off of here. Now there's also supposed to be a backing shield. Mine is missing. Looks like it rusted off a long time ago, so I'm not too worried about it. Also, the ABS sensor does not need to be removed. It is not in the way. Once again, take a hammer, tap it side to side, top and bottom, until this breaks free. And there it is. We have to clean all of this corrosion, so I'm going to take a fine sanding disc and clean this. Now, this is aluminum, so whatever you do, don't get anything that's going to remove too much material very quickly, such as a very coarse grit sanding disc. So if you have a sanding block, that'll be good too. Maybe chisel some of this rust off and then sand it flat. Basically, you want to make sure that the new wheel hub will mount flat and won't be stopped by any of this corrosion. Now with it cleaned off, let's rinse it off with some brake parts cleaner, get rid of all this dust, debris, and any oils or grease that might be stuck in here.
With everything cleaned up, I'm going to put some anti-seize on the surface where we clean to prevent further corrosion from building up. I'm also going to put some on the splines of the axle so that it doesn't seize in the new hub in the future. You want to keep this layer thin so that it doesn't squish out when everything gets bolted on and go all over the place. From the old hub, I ended up taking what's left of the backing shield as well as this little plate because these actually act as a spacer to properly space this hub out since they are quite thick. So I decided to take them, clean them up the best I can, and put them back on since I don't even have a new backing shield. This is the least I can do to get the spacing correct between the hub and the knuckle. So now I'm going to line everything up, make sure the axle pushes through, get my bolt holes lined up, and with this somewhat in place, get one bolt lined up and thread it in partially. And with this in, you can let go, it'll stay a little bit better in place, and then get another bolt lined up and thread it in partially, which should make this completely lined up for the other two bolts. Perfect. Now I want to tighten this up in a cross pattern to make sure that the wheel bearing and all these pieces here get squished onto the hub evenly, not at an angle. So it doesn't matter where you start as long as you go in a cross pattern. I have my air tool set on the lowest setting because I want to just bottom this out and then I will torque it. The torque on these bolts is 51 foot-pounds. At this point, you don't necessarily need to go in a cross pattern, although I will, but since it's snugged up already, everything should be seated properly. All right, double check them if you want. All right, that's installed. I'm going to put the axle nut on at this point, thread it on by hand, and then we'll bottom it out and snug it up. The torque is 217 foot-pounds. I'm going to use a power tool to snug it up, but I'm not going to blast it on there. I want to make sure that it's properly tightened. To hold the hub from spinning, I'm going to use a pry bar right between the lug studs so that as I tighten this, I can hold the hub. Once again, 217 foot-pounds. Here we go. All right, that's it right there. The only way to lock in this axle nut is to stake it down right in this opening of the axle on the threads. So take a chisel and a hammer and hammer it down right in the middle. Doesn't have to be a lot. That should be plenty right there. That's just going to prevent it from backing off by itself if the vibrations cause it to do so. Apply a thin layer of anti-seize to the surface of the hub. This is going to prevent rust from building up in the future and will allow the rotor to sit nice and flat for a long time. If it doesn't sit nice and flat, that's going to cause brake pulsations and therefore uneven wear on your brakes. Now you also want to make sure you don't put too much on, because if you put too much anti-seize, it's going to fling out after the rotor goes on and it's squishing the anti-seize out, therefore getting all over the inside of the rotor, potentially your wheel and other components. You want to make sure you cover the inner hub bore right here where the rotor and the wheel sit. That's going to prevent both of them from accumulating corrosion. Reinstall the tie rod end stud into the knuckle, thread on the mounting nut. We'll bottom it out. Torque this to 48 foot-pounds. If you still have the original cotter pin that has a hook on it, reinstall that. If not, reinstall a new cotter pin. Make sure that hooks into the hole on the side, and that's locked in. If you're dealing with a used rotor, you want to make sure the hat of the rotor inside right here is clean and flat. For the same reason that the hub should be flat, you want to make sure this mounts flat to the hub. Otherwise, it's going to create vibrations, and sometimes it's even a good idea to clean the outside of it. Reinstall the rotor on the hub. In order for it to stay on, what I'm going to do is use an old axle nut and a lug nut. This will hold it on the hub without it wobbling around so we can work a little bit easier. There. Reinstall the caliper and bracket assembly onto the knuckle. Have at least one bolt ready so you can line it up. That way, once one lines up, you can somewhat let go and line up the other. Snug them both up. And we'll torque these to 100 foot-pounds. Now, when you torque these, if your bolt head has 2 little lines on it, torque them to 100 foot-pounds. If it has 1 line, you torque it to 58 foot-pounds. Mine has 2 lines, so I'm going for 100. All right, these are torqued. Don't forget to reinstall the bracket for the ABS wire back on the knuckle now. Thread in the bolt, make sure that little hook goes into its slot. Bottom this out, and just give it about 1/8 of a turn after it bottoms out. That's bottomed out and snugged. And that's it right there. You just need to hold on that bracket. You don't want to strip out the threads in the aluminum knuckle. Let's get the wheel back on. Start on all 5 lug nuts. We'll bottom them out in a cross pattern, and also in a cross pattern, we'll torque all of them to 76 foot-pounds. If your vehicle has the locking lug nuts with the key, be very, very careful with these. I don't recommend using a power tool on them. I'm going to use one just to slowly bottom it out, but I'm not going to impact through this adapter because the teeth on the backside can very easily break. Once again, 76 foot-pounds in a cross pattern. Double check them all. Remove your tool if you had one of these here. There you have it. Take it for a road test, and don't forget to get in alignment.
When only the best will do, demand TRQ. The only company that lets you view before you do. TRQ is committed to offering the highest quality aftermarket auto parts that are engineered for peace of mind. Thanks for using and viewing with TRQ.